So the exercise. So here it asks you to find the enthalpy of combustion. Enthalpy of combustion of liquid octane. Okay, phase dia pun penting, liquid or vapor. So at 25 degrees C, 1 atm. Using the table is 26. So assume water in the product is in liquid form. So water dekat sini, dia dah mention liquid form. So dalam table, you should refer to liquid properties. First step, okay, in this question, sebenarnya dia tak ada bagi equation ni pun. So first step, you need to generate the combustion equation. Liquid octane, C8H8. So this one is the common combustion equation. Mole of CO, which is X. 9H2O, which is the Y over 2. Okay, so sekarang kita kena cari A. This one X twat. Dia tak ada mention excess air or anything. So assume X twat. So here A, macam mana nak cari A?
O2 kita balance oxygen left side yang gel.
Boleh juga, that one long way lah.
Oh, okay.
Yang kita guna equation tu. X plus Y over 4.
X plus Y over 4. Okay.
Okay, so kita cari X plus Y over 4.
What 25?
Betul. Okay, so then include in the equation. Ini pun 12.5 for the nitrogen. Okay. Okay, then dari situ kita boleh identify how many moles of the product and how many moles of the reactant. Because the infos are required to find the heat of combustion, where heat of product minus heat of reactant. And then this heat of product is the total heat produced by the product. The total heat means you should involve the N, which is the mole of the product. Okay, now we extend the equation. Product is the CO2, H2O. This is the product part.
Okay.
Product. Sini kita ada CO2, H2O and N2. So kenapa tak involve N2?
N2 because kalau tengok table atas tu enthalpy of formation. For nitrogen 0.
Yes. HF for nitrogen 0. So that's why kita tak include the N2. Bukan tak include, meaning that dia dah 0. Kan? So minus the reactant. This is reactant part. Reactant. So this reactant part also the same reason why there is no O2 and N2. involved over here sebab dia dah 0. HFO2 pun 0. Yeah. Okay, so find the infos from the table. You will get this figure. Table A26, which involve only HF. So in here, okay. Sekejap saya buka table. Jadi dia kata obtain liquid. Obtain liquid. So here kita ada 2 octane value. So choose the liquid.
Liquid. Okay.
So that's why the punya HF is negative 249. Okay, so back to here. That's why HF sini is negative 249.
Yang tadi tu octane, liquid octane.
Liquid octane. Ni.
Hmm.
And octane.
Okay.
Liquid. Okay.
Okay.
Then, you do the calculation, try to calculate whether you get the figure. H2O tu ambil liquid lah. Value for liquid. So that is why negative 285.
Negative 547,068. Okay.
Almost there. Jump per K-mol. If the question requires mass basis, then divide by the molecular weight. Molecular weight.
Okay. Kalau soalan minta mass basis.
Kalau mass basis. Kalau dia tak letak apa-apa requirement, usually end up the unit will be kilojoule per K-mol. Because why? Because dalam tables is kilojoule per K-mol, the unit. Kalau the question requires for mass basis, kilojoule per kg.
Kilojoule per kg.
Mass basis. Kilojoule per kg. Kg is mass lah. Mole basis, mole lah. So kalau mass basis, the mole ni is divided by molecular weight.
Okay, mole divided by molecular weight.
So mass basis over here, the mole basis that you get divided by molecular weight of the fuel.
Jadi cakap divide by molecular weight of the fuel.
Fuel.
Semua
Semua maksudnya?
kan nak dapat value kilojoule per kg tu, number of moles tu divide by respective molecular weights kan? Ataupun
fuel saja. Yang final answer ni, final answer ni,
okay.
final answer divide by molecular weight of the fuel. Okay, sini molecular weight fuel dia octane. So C8, C12 multiplied by 8 plus 18 1.
Negative 47,988 from there.
Okay, copy that. So similar to the answer here. The final answer only divide by molecular weight. Dia boleh je kalau you nak buat. Tak. Kalau each of these you nak divide, then it will be different thing lah. Each of the HF. Different thing. Okay. If the water is in gas form, so value sini akan jadi lain. Sini tadi liquid kan. Okay. So this one, the previous example. So kita go step by step. Liquid propane. So ini liquid propane. This is liquid. Enters a combustion chamber at 25 degrees C at a rate of 0.05 kg per minute. Okay, this one, liquid propane, mass of the fuel, mass flow rate, mass dot F. Then it makes and burn with 50% excess air. Enters combustion chamber at 25 degrees C. Okay, the air is also at 25 degrees C. An analysis of the combustion gas reveals that all hydrogen in the fuel burns to HO2. Only 90% of the carbon burns to CO2, 10% to CO. Exit temperature 1500. So it asks you to calculate the mass flow rate of the air. M dot air. Okay, so this to find the M dot air, usually it will involve yes, air fuel ratio. Formula of air fuel ratio where M air over M fuel. Okay, tapi kita punya air fuel ratio unknown. We just have M dot fuel. We have two unknowns. So kita kena cari air fuel ratio dulu kan. Actual. The actual air fuel ratio. Okay. First thing, always generate the combustion equation. Okay, we go for the Stoic first.
Boleh. Okay, we go for Stoic equation, where you should find the A from the equation, the A x plus y over 4. Okay, yang ni boleh guna equation. Yang atas tu dipanggil ni Stoic equation. Sebab yang ni dia tak involve the excess air.
SSA. Okay.
Dia tak involve excess air. So A boleh guna equation ni untuk cari. Atas sini dia mention boleh buat auto balance juga. Either way lah. Okay. Okay, so then we generate the actual. Actual means bila your product has the O2, excess air. And then from the statement just now, it mentioned your C 90% converted to CO2. Okay, so 90% of the C converted to CO2. So 90%, sorry, 0.9 from 3 carbon from the fuel kan. From 2.7. Okay, so that's why kat sini dia dapat 2.7. The remaining, so the remaining 0.1 times 3 will get 0.3. This one CO2. Okay, that's how you get the 0.3. Okay. Now 50% excess air. Sini A tadi is 5 kan? 50% is 1.5. So 5 multiply 1.5. Dapat 0.5 kan? So 1.5 multiply by 5. Okay, so to get this,
Seven, apa? Try to balance.
balance. Betul. This one kena balance. Try dulu tak? Empat. 2.65.
Okay, so you should do the balance up to find the unknown excess air, unknown mole of the O2. Okay, so from there, we need the A, actual A, to find the AF actual. Okay, so to find the AF actual, the A you calculated, multiply by 4.76, multiply by molecular weight of the air, divide by molecular weight of the fuel. Okay, then you get this. Once you get the AF, plug in into the equation, the initial equation, then you can get the M dot air. So this one tadi tu yang AF M dot air over M dot fuel. M dot fuel is given 0.05. Bennett, are you there?
Yes, Miss. Yes.
Okay, can understand?
Yes.
Can understand? Do you have any question?
Yes, I understand.
Okay.
No questions.
Okay. Okay, now we proceed to find the rate of heat transfer. Rate of heat transfer. So here, ni dia dah bagi solution. We try step by step. Q dot, so it involves the product minus reactant. Heat of product minus heat of reactant. So first thing, list out the component. List out the component first. Your feed, your reactant. This one, the fuel, propane liquid, air, product. O2 in your product as well. Then each of the component find out their heat of formation. This one from table A26. Propane liquid.
Zero.
Heat of formation, yes, 0.
H2O in liquid form or
Gas tu tadi dia kata. Dia dah mention tak? If no mention, we can assume as a vapor.
liquid.
Dia tak mention. So we assume as vapor. This one, fuel, we remain as in gas form. Because from the table is A in gas form. Yeah, gas. Sebab kalau liquid, you need another step to convert it into liquid. We just remain in gases. CO2.
Uh,
241.
41820.
393.
3520.
0.
520.
Okay, for HF, clear. Next, we should find the H at temperature, specific temperature. So 1500 for both, for all components. Okay. So, propane memang tak ada. Okay, we look up for the O2. Or H2O lah, which one you found it first. So for H2O, 1500. Five seven nine nine. Betul.
Yang ni oksigen.
You cari oksigen dulu. Okay. 49. 49292.
Bagi bukan yang Miss cakap tadi untuk oksigen.
Yang oksigen 49292. Betul.
Oksigen 49 to 92. Oksigen 47. Nitrogen 47 073.
Betul.
So, PA2 71 07.
Ya, betul. 71078.
Okay. Carbon monoxide 37,517.
Yes. Okay, next cari 298. Earlier version you find at P1500. Just find together for 298. Yeah, about all these numbers. Then plug in into the equation. Terus susun balik semua. Produk step by step. For CO2, and then N multiply by the HF.
Dalam exam ada markah untuk tulis ada.
Ada.
Ya.
Hmm.
Tulis satu.
Kalau exam, usually markah yang you cari value for the HF apa semua ni pun ada marks.
Ada marks. Maksudnya table ni ada mark.
Table ada marks. Kalau you tak letak dalam table, so mungkin you just
Direct tulis.
direct to the equation ni kan. So saya akan cari dekat equation calculation. So this one for CO2 plus CO. Be careful on the sign.
Ini kalau dalam industri mesti pakai Excel ya. Tapi ini
Ada software lah.
kan.
Dia dah ada software.
Ah.
Input the value je.
Hmm.
But still you need to know the fundamental lah.
Kalau reactant tu yang air tu kita tak payah ni. Tak payah ni yang 7.5 tu. Tak payah macam. Tak payah
Tak payah sebab HF dia dah zero. O2 dengan N2 dah zero.
sebab dekat produk kita dah kan maksud saya
Ada change in temperature. Betul juga. Okay, dalam question ni, air pun enter at 25 degrees C. Original question sebenarnya, air tu dia enter dekat different temperature actually. So kalau you notice, dia ni actually 7 degrees C.
sebenarnya
Ini manakah? Betulnya dah cross out. Ni. Kalau different temperature, then ada. Dia ada HT dia tu. Kalau let's say at 7 degrees C tu, so dekat sini tadi, you have extra table H at E equals to 7.
untuk reactant je.
Untuk O2 dengan
N2.
N2, yes. Akan ada value lah kat sini.
Value ni kalau dalam equation equation yang HF plus H minus H. Apa tu? Lepas tu yang H baru tadi yang kita tolak juga lah.
Untuk reactant.
Ha.
So kalau ni let's say okay, saya padam ni. Let's say sini ada at 7 degrees C. So sini akan ada lagi minus 7.5 for O2 HF0 then
plus H, ni lah, H at T7 tadi, kan? Then minus H at T25.
Tapi dalam syllabus kita tak. Tu boleh, benda ni boleh jadi dalam
Boleh.
lah. Boleh.
Dia possible to happen. Dia ikut case by case lah. Condition combustion tu lah, dia requirement dia macam mana. So kalau ada perubahan suhu other than 25, yes, you should include lah. Macam ni. Tapi since question ni dah fix at 25 degrees C, so cancel out everything, kosong lah. So that's why in reactant part, we don't include the O2 and N2. Dia bukan simply kalau reactant fuel saja, no. It depends to the condition. Kalau ada perubahan suhu, then let's say the fuel combustion chamber, then the fuel and the air enters at not at STP. Dia ada pressure dia ada temperature dia. Then you should consider. This one basic, I ajar ni yang basic je.
Okay.
Industry banyak case lah. Industry just enter the key in dia, nanti ada lah. Tapi nak set up that final answer, this fundamental. Okay. So I delete back the 7 degrees C tadi. And then I just remain for the reference. Okay. Okay, final answer tadi dapat berapa?
Ini betul.
Disconnect.
Dia cakap dia dah pernah ambil subjek ni.
Dah.
Lepas tu dia cakap, oh dia dah hafaz lah. Tak tahu lah.
Asal? Aku tak ingat.
Tak, dia cakap subjek ni macam senang lah. Dia cakap macam tu.
Dia kalau pernah ambil temu, natural balance, yang tak susah sangat lah subjek ni.
Dia cakap macam, dia cakap senang. Lepas tu saya ingat dia dah hafaz lah. Kenapa dia repeat je kan? Tapi macam lari sikit.
397.
397 dapat. Kita
397 something lah. Okay. Hopefully there. Negatif kan?
Negatif.
Dengan 7 plus. Okay. Then the unit has to kilomole per fuel. Kilojoule per kmol. Okay, unit pun you kena mention in the final answer. Unit is very important. Tak boleh left out. Sometimes dalam, even though kalau design, kita miss out the unit, kita silap unit pun akan effect the design. Yeah, that is something. Okay, so we're done with 3A. Interesting. Okay, basically heat of combustion, heat product minus heat reactant. You just need to check what is the condition, the temperature, then the phase.
The phase, of course.
Yes. Okay. Break sekejap ke?
Boleh continue.
Boleh continue? Boleh continue? Okay, so untuk this chapter, you are given the final temperature. You are given final temperature. And the final temperature of the combustion. For the next part, chapter 3B, which is the adiabatic. Before that, do you understand the term adiabatic?
Change, no heat. Sorry, no change in temperature.
No heat release.
No heat release.
Yang sebelum ni, Q, kita cari Q kan? Yang sebelum ni, fuel, input, then you have output product. Then you are asked to find the Q. Kan? Okay. So you're given the T out. Nampak tak? Ada? Chapter baru, 3B. The one I thought is the clean version ke? Not.
3B saya tak ada ni.
Okay.
Saya tak download ni.
Okay, boleh proceed. Okay, previously kita given the condition T output and then you need to find the Q. Okay, sekarang when it involve the adiabatic means Q equals to 0. So to find out macam mana condition so that Q equals to 0, usually you will need to determine the adiabatic flame temperature, the T out. So sini we call T adiabatic, where the Q is 0. Q kita dah known. Need to find the adiabatic temperature. Similar step, total heat of product minus heat of reactant. But product tadi, the T is unknown.
Okay.
Kan?
Ya. Okay. Tadi T is known lah. Jadi kita cari Q.
Yes. H product minus H reactant. So H product ni dekat non T out. Kan? Tapi sekarang T out ni is unknown. We need to find that T out. The same equation. For adiabatic, kita ada two condition, whether constant pressure or constant volume.
Sebenarnya.
Both will have different equation. Now, the definition of the adiabatic flame temperature is the highest temperature that can be achieved in a combustion system, where there is no heat exchange to the surrounding. Okay, and all it depends to the air-fuel ratio, the AF. Maximum flame temperature occurs at start air-fuel ratio. Then even higher when using the pure oxygen. Two types, constant pressure and constant volume. Okay, now for constant pressure, this is the equation. Constant pressure, okay. Heat of reactant equals to heat of product. So constant pressure, the pressure is the same. We just need to find the T adiabatic, T of the product. Okay. Okay, we go for constant pressure first. Consider liquid octane. The same example as previous. 50% excess air. So it asks you to calculate the adiabatic flame temperature. TAD. Okay, given combustion reaction to this. If it is not given, you need to find out. Okay. Now, from the first law analysis, from the similar to the previous equation. Now, the strategy is, this is unknown. T adiabatic is unknown, thus the H is also unknown. Okay, so macam mana nak cari? We will guess the adiabatic temperature. Then we will do the interpolation.
Gas.
Kita akan two different temperature, calculate at two different temperature, then we do the interpolation. Okay, we know the adiabatic given Q adiabatic is 0. Okay, at certain temperature, you akan dapat what is the H. Sorry, this is H. H ada H dia, like T1, T adiabatic, T2. Okay, so you akan guess this value. So that the Q equals to 0. Okay. And then we go to the equation. Okay, let's say we guess the temperature at 900 and 1500. So the reactant heat of product minus heat of reactant equals to 0. Okay, kita guess at 900 and 1500. Find all the values at that particular temperature. Okay. So bila still the same, cari the HF, the sensible heat, everything. You akan dapat at T900, this is the Q. Boleh follow?
Boleh.
Then the second T, you will get this value of Q. Okay, then we do interpolation or extrapolation by using the Q value. So at T adiabatic, Q must be 0.
Yeah.
So from there, you do the math, then you will get the T adiabatic. Yeah, so sini tadi, this is Q, sorry. Okay. At Q, at T adiabatic, Q is 0. Here you will have your value.
So not necessarily one positive number, one negative number. No. So basically any two different numbers.
Yeah. I need to do another. How to guess? Usually, I would suggest to go max 1,200 lah. For the guess lah. It can go up to 2,000. It depends on your guess. So the lowest usually 800, 900. Actually ada another step which is more detailed. Using the enthalpy calculation. Like detailed step. This is the easiest way to get the temperature. Then from there do the interpolation. Okay, we try the example over here. This one I extract from Thermo books. Mechanical Thermo book.
Mechanical thermo, okay.
Chapter 15. I think combustion dekat chapter 15.
So saya macam pernah belajar sebenarnya.
Nah,
Adiabatic film.
dalam apa apa?
Thermo tu.
Oh, Thermo tu.
Thermo ni, thermo mechanical.
Belajar ni senang sikit lah.
Adiabatic film.
Okay. So the fuel, which is the methane, CH4 with the air. Adiabatic flame temperature of methane when it is burned with 30% excess air. 30% excess air. So dia punya produk ada apa?
Produk ada CO2, H2O, excess. N2 of course, O2.
Yes, O2. 30% excess air. So first thing first, generate the combustion equation. Okay, sini excess air kan? Excess air, so that means it is not extract already. Betul?
Start of course.
Dia nak P adiabatic. Okay, then combustion equation would be CH4 and the A unknown. First thing, kita nak cari A. A ni, dia dah bagi 30% excess air. So dekat sini is 1.3. Theoretical air kan. So A dia, you can find from the equation. X plus Y over 4 tu. Kan? Okay, tu. So, ini A start. Ini A actual.
So 12 times 1.3.
Correct.
2.6.
2.6. A is 2.6. CO2 tu berapa?
CO2 is one.
1 lah. Kan? 1.
One.
H2O?
Two.
2. O2?
Itu kena balance je.
Yes.
Zero point six. Yeah,
Betul tak? Bagus ni.
we dapat 0.6.
Bagus ni. Kita assume 0.6. Dia dah buat balance lah tu.
Tapi tak tulis lah, just
Okay. Okay. Let's say 0.6. Then, once we get the combustion equation, the final combustion equation, next step is to find the info. List down the component CH4, O2, N2, O2, H2O. Then find the HF. Then assume the two temperature.
Okay.
H at T1, let's say you assume 1,900. Sorry, 1,000. Let's say you assume 1,000, then 1,000 or 2,000. Let's say between 1,500 to 2,000 lah. That's all. So these are the info that you need to find. HF as usual at A26.
Negative 74.
Untuk methane kan. Negative 74850.
When you try proceed, nanti your T adiabatic, you akan dapat around this range. Okay, if T assume 1,000, 2,000, so you will get around this figure. The T adiabatic value, it depends to the T of the two gas T.
Oh, okay.
Ah,
Oh.
Ini kalau 1995, if you assume between 900, 1,500. But the range is there, around 19 something to 2,000. It depends. As long as your T adiabatic is in the range, then it should be correct again. Unless kalau you calculate, then you dapat 1/6 something, then out of the range, wrong something wrong somewhere. Okay. Kalau dalam buku thermodynamic tu, dia guna method yang calculate enthalpy. Different. Itu lagi panjang dia punya calculation step. Ada?
So ni adiabatic kan?
Hmm,
Nah ni adiabatic frame
Hmm.
temperature.
Hmm.
So contoh soalan
So, we could obtain. Ini dia substitute apa? Yang ni dia guna enthalpy macam ni. Different step. You ada range then you ini. Itu lagi panjang calculation dia.
lagipun dulu lecturer tak fokus sangat kat sini sebab semua student clinical. Ni dia tak fokus sangat.
Oh, okay. Ni you energy, you kena, I think sebab apa, this one as core. Energy kan, apa, biomass, combustion kan,
Betul.
sustainable energy. Okay, kalau mechanical, dia combustion dekat dia punya internal engine. So, I think kita talk as stage boleh. Nanti you try proceed whether you get the range. Okay, so next class. Bennett, any question?
No, miss. But
Okay.
I will
Make sure you understand.
Yeah. I'll
Okay,
look back
so
the recording because just now
Okay.
I disconnected.
okay. So next class is on next Tuesday. I will do offline class. I will do offline. I might give you some exercise, or I share with you the recorded lecture. Then you do the exercise. So submit the exercise as proof of attendance. The submission of the exercise can be at the end of the week. Just enjoy your holiday. Okay, so that's all. Bennett, Hamizan, thank you for coming.
So